And this is Tim Hegarty again with the Virtual Training Company C++ Fundamentals. Now we're going to look at class templates. We just looked at function templates and saw how to use those. Now we're going to look at class templates. And it gives you just about the same functionality. It's really allowing us to create classes without specifying the types that will be used as input to those classes or stored in the classes and so on. For example, there's a template, class T, they like T again, and this is now going to actually create a class called myPair. Now myPair will have two values in it, and they will both be of type T. So you can see that right there. Type T, that's going to be this same T, whatever this gets brought in when we create the class. Char, int, float, double, whatever. Then we have our public access specifier, and we have our constructor for myPair, has the same name. We'll take in two T's, first and second, are going to be of the same type, and then we're just going to define values. Here's our little array. Sub 0 equals the first one, value sub 1 equals the second one. So that's our constructor, very, very simple. Let's take a look at a little bigger piece of code with this in it, and here we are. We have our template class T right there, and here's our class definition, myPair, and there's A and B are both of type T, whatever that will be. Here's our constructor using the T types just like we just looked at, and now we're going to have a member method called getMax, and it will return type T. Also specified from there. These are all the same T. Whatever they happen to be, char, int, float, whatever, they will get turned into that during the running of the program. All right, now down here we have, again, the template class T. We have to specify that again so that we wrap this properly, because now we're going to create the member function getMax by using the return. It's the myPair class of that type. Got to specify that type in there again, and then getMax is the actual function name. And inside getMax, we will have, as we define getMax here, we will have a return value of type T, whatever that is. The return value is again equal to the comparison, A greater than B. If it's true, send back A, otherwise send back B, and then return it. Or you just put that into return value and then you return value. And here's main actually using that class and that member method. Here's myPair. We're going to create of this class. That's the class name. And there's the int. Int is going to be all throughout here where T is. It'll be changed into int. And myObject is the actual name of the instantiation of the myPair class. And we're going to stick two values in there. And those two values, that corresponds to our constructor, first and second, that we had up there. So first will be 100 and second will be 75 in our little example. And then we will do the console out of myObject.getMax. So we'll take myObject, use its method getMax, and getMax understands that it is supposed to be working on integers because it knows the class type, and then just an end line. All right, let's see if this actually does it. And 100 was the larger number of the two that went in. 175. So it works exactly the way we thought it would. Pretty simple, and we hoped it would function properly. So get a very good understanding of these templates and how these templates can work by looking through this sample code and changing this up a bit to use some characters, modify this code a bit and use characters and floats and pass some different numbers and see what's happening there so that you can see how the template classes are working.
Hi guys, welcome to the C++ programming tutorials. So in this tutorial we're going to learn about the templates and the generic functions in C++. So let's say in your program, you have to write a function, which is going to work on the integers and the floating point number, and it's going to do the same thing. For example, you need to write a function, which is going to check for two numbers and it's going to return the largest number. So what you can do is we can write the function with the same name and different type of parameters. For example, let's say int, and I'm just going to call it as max. That int is return type, and here it can take two parameters, int x comma int y, and it can return, and we can check whether x is greater than y. If it is so, we're going to return x, else we're going to return y. So now this function can work on integer type of data, And if you want to write a function with the same name and you want it to work for the floating point also, what I can do is I can copy this, paste it here, and I can change this data type to float. Okay, now we have written the same function, the same logic, but for different data types. So we can use that in our program. So for example, let's say max, and I'm just gonna pass two numbers, let's say 2, 4 or whatever it is, and I'm just gonna build and run, and we get 4. Now I can pass floating point number also, 2.23 and 2.12, and if I build and run, you guys can see we get 2.23. Alright, now we have overloaded this max function, or we can say that we have written the same logic 2 times just to make it work for different data types. So what if we can write this function only once and make it to work on different type of data types? So we can do that in C++ by using the templates and the generic functions. And first of all, what is a generic function? A generic function defines a general set of operations that will be applied to various types of data. For example, here in this case, if we can able to write a function which can work on these integers and the floating point numbers, then that function is gonna set to operate on different types of data, and that function is called a generic function. The type of data that the function will operate upon is passed to it as a parameter. Just like the way we are passing the parameter to this max function here, we're gonna pass the type of data that our generic function is gonna operate. So we can say that through a generic function, a single general procedure can be applied to a wide range of data. So the next thing you guys may ask me, like, okay dude, what is the use of this generic function? What happens, or why we need to write a function which can work on different types of data? Normally in programming, in many cases, many algorithms are logically the same no matter what type of data they're gonna be operating on. For example, let's say you have to write a quicksort application where the logic or the algorithm is same whether you are using an array of integers or an array of floating point numbers, but the only thing that differs is the type of data that we're gonna be working on. In this quicksort example, if we were able to write a generic function, then our generic function is going to define the nature of the algorithm independent of the data. So once we have done this, the compiler will automatically generate the correct code for the type of data. When we pass integer type, it's gonna make that generic function to work with integers. When we pass floating point values, it's gonna make that generic function to work with the floating point numbers. So in other words, we can say that when we write a generic function, we are creating a function that can automatically overload itself. And if it is confusing, don't worry, when we see the example and when we use the generic function in our programming, it's gonna be very clear and easy to understand. Alright, to write a generic function, a function which can work on any type of data, we need to use a keyword called template. And then we need to write a less than symbol and a greater than symbol, and between that less than and greater than symbol we need to write a keyword. It may be a class, the keyword class, or it may be type name. You can use either class or type name. Both of them are gonna do the same thing. And then after that keyword, we need to write an identifier that the function that we're gonna define is gonna be working on. So here, just an identifier. It can be anything, any name you want to give, you guys can give. For example, let's say identifier, and then we need to write the function. Just similar to any other function declaration. First, we need to write the return type, and then the function name, and then in parentheses the parameters that the function is going to be working on, and then the function body. So here, these parameters that this function are going to be working on are going to be of type this identifier. So if it is again confusing, don't worry, when we see this in example, it's going to be clear. Alright, now in this tutorial, for the demonstration purpose, what we're going to do is we're going to write a function which is going to print out whatever values we're going to pass to it. It may be an integer value, or it may be a floating point value, or it may be a string. Whatever we pass it to the one function, is going to print it out. So we're going to write the generic function right now. So first we need to write the keyword template, and then we need to write less than symbol and greater than symbol, and here we can use either class or type name keyword. I'm going to write type name, and then let's give a name to the identifier. Let's say my type, and then we need to write the return type of the function. Our function is not going to return any values, so it's going to be void, and then the function name, let's say display, and then in this parenthesis we need to pass the parameters. Let's say our function is going to take one parameter. So here, this my type is a placeholder name for the data type used by this function display. So we don't know what type of data it's going to be taking, maybe integer, float, or string. So we're going to refer this placeholder here. So it's going to be my type, and then the variable name, let's say x, and then we're going to define the function body. So here I'm going to use a cout, and I'm just going to say you have passed, and then I'm just going to refer to this x, and then we're going to end this line. So that's it. Now we have defined a generic function by using the templates which can work on any type of data. So I can use this function display now in my program and pass any type of data. So here, for the demonstration purpose, we're going to call this display function. So now in our program, we're going to call this display function and pass the parameters. So I'm going to write the function name, which is display, and then I'm just going to pass an integer value. Now when we compile this code, the C++ will come to know that okay, this display function has to work with integer type of data, and that's why it's going to make it to work with integer type. In other words, we can say that this my type is going to refer to the integer type, and I'm just going to build and run this, and you get you have passed 10. Now we can use this same function and pass floating point values, string values, double values, whatever we want. I'm just going to pass 1.2345, and here I'm just going to pass Anil Shetty rocks, and I'm gonna add the codes here, and I'm just gonna save it, build and run this, and now you guys can see you have passed 10, you have passed 1.2345, you have passed the Anil Shetty rocks. The same function, it is working on different types of data. So here we have written a generic function which is working on different types of data. So we can say that a generic function defines a general set of operations that will be applied to various types of data. And to create a generic function in C++, we're going to use the template keyword, and this is how you guys can write a generic function. So this is it, guys. This is about the generic functions and templates in C++. Thank you for watching, and don't forget to subscribe. In the next tutorial, we're going to be learning some more about the generic functions in C++, and I'll see you in the next tutorial.